Hello everyone. So this is the second video of the AMC 22's. So if you didn't see the first video, so I'll just attach in the description so you can take a look at that. So the number six is 2009 AMC 22, right? So the question says how many whole numbers between 1 and 1000 do not contain digit 1? So like when you see like at least or does not include or do not contain and stuff like that, we usually like to find what we do not want to like find. So that's easier to count, which we call complementary counting. But let's say if we can do it with this question with the cases. So we want to have the numbers like 1 through 1000, right? So I'll just say we can just think as like 1, 2, 3 digit. So, and then we can just assume every number from 1 all the way to the 999 can be written in terms of like a three digit. Like, for example, if I want to say like 27, so this could be written like 0 to 7. If I want to say 1, so this could be written like 001. So, which is why if I start with 1 all the way to 999, any number can be written as like three digits like this. So what we want to find is the numbers that does not include 1. So since we know that we have 10 digits, 0 through 9, so we could say 9 is okay for this one, including 0, because if I have this is 0, that will be 0 and two other digits. So it looks like maybe like this or that way. So the same reasoning with the second one and the third one. So if you multiply this by the multiplication principle, so you got 729 numbers that is available. But of this, as you see, there is no 729, there is 28. But the reason why 729 is not the case, because when you say 9 option, 9 option, 9 option, you're choosing one of these like 9 as like zeros, right? So this if this is 0, this is 0, this is 0, that will just give us the 0. But we start with 1, so we should subtract 1 out of this, so which will be 728. So that's the answer. So if you didn't see this, or if you are not satisfied with this completely, then you can go with the cases. Like cases, like we can just say case 1 as one digit numbers, right? So if that's the case, you are not allowed to use 1. So 1 through 9, there is 9 digits. So, but except 1, so there is 8 of these that is available, which we can have. And the case 2 is like two-digit numbers where we do not want to take the one again. So we could have like 0 and 1 is not allowed for the tens digits, so we have 8 option, and then we can have 0 but not 1 anymore anyway. So that should be 72 two-digit numbers. And then case 3 is the three-digit numbers. So I could have 8 option for this again. So 0 and 1 doesn't work. And then I have 9 option for this one, and then 9 option for this one. So if I multiply these, so you will get 8 times 81. So that looks like 8 times 8 is 640 plus 8, so 648. So if you add these two, that's 9, like 80 plus this would be our entire sum. So you will get 728 again, which is the same answer. So that was the number 6. So let's see the number 7. So the hundredth digit of a three-digit number is 2 more than the units digit, which is like ones digit, right? And the digits of the three-digit numbers are reversed, and the result is subtracted from the origin three-digit number. What is the units digit of the result? Okay, so like there's no really concrete information other than having one digit is 2 more than the other one. So if you are not sure what to do, you can just start with exploring. So it says the hundredth digit is 2 more. So let's say this is 3 and this is 1. The middle digit could be anything. So for example, I can choose 3 for 1. And if I reverse it, I will get 1 of 4 and 3. And I will just subtract the new number from the original number. So that's what we are told right here. So just be aware. Otherwise, you're going to get 2 if you do the other way around. So now 1 minus 3, which is like 8. So because we carry 1, that's 11 minus that. So if you just subtract, so you get 9. I mean, 3 minus that will be 9. And then you got 1. So 198. So which is going to be 8 is the answer. But if you're not convinced, like you can try some other numbers. Let's say we start with 5. And then let's say 4. And this is 2 more than 3. So if you swap these, you get this number. And that will be 13 minus 5, which is still 8. And 3 minus 4, which is 9. And then 4 minus 3 is 1. So we still get 198, and the unit digit is 8. So on the test, you can just go with this. You don't have to prove this and stuff like that. But if you are like doing this as a practice, like you may ask why this is always the case, or is this always the case, right? So you can just say like ABC is like a 3-digit number when you swap it. So you get C, B, and A. And our goal is just to subtract these. So the top number I can write as like 100A and 10B and then C. And the bottom number is 100C plus 10B plus A. And our goal is to subtract this from the other number. So you see this guy will add up to 0. So 100A minus 1A is 99. And then C minus 100C will be minus 99. So that should be A minus C. So since we are told A is 2 larger than the C, which is A minus C is 2. So you get 99 times 2, which is 198. So regardless of what number you chose, you always get last digit to be 8. So that is just the answer. Okay, so that is number 7. Here's the next one. So we are looking for the tens digit of 7 to the 2011. So whenever you are trying to find the last digit, modular arithmetic is like what we usually use, and to see if that is kind of give us something that we like. And if you don't know what modular arithmetic is, it's just like a fancy way of saying the remainder in a different way, but it has a little bit more advanced tools as we go. So you can take a look at more details. I'll share some in the chat in the description soon. So anyway, so otherwise you just find a cycle in most basic approach. So we are looking for the tens digit. So if you are interested in 10 digit, you just need to know the last 2 digits. So which means you are going to divide this 7 to the 2011 by 100. So our goal is this 2011 is going to give us something, let's say 2-digit numbers. So I'm going to call that's XY. And we are going to divide this by 100. And then we say mod 100. So to start with, we're going to start with the powers. Okay, so 7 to the first power is, we are going to use congruency instead of equation. So that's going to be 7 by divide 7 by 100. So when you divide 7 by 100, so that will be remainder. And that is just basically what that means in a one way. And the 7 squared is 49. So that is also 49 when you divide by 100. And 7 cubed is, you can take the 7 cubed, or you can multiply 7 to the first by 7 to the second, or you can just multiply these two. That will give us 7 to the third. So 7 times 9 is 63, and 7 4 is 28, plus 6 is 40, like 34. But we don't want to write 343, so I'm going to just write 43 because we are interested only last 2 digits. And we just continue this until we get 1 or somehow easy number to deal with. So 7 to the 4, you multiply 7 by 43 because 7 to the first times 7 to the third is 7 to the fourth. So 7 times 3 is 21, and 7 4 is 28 plus 2 is 30. So that means last 2 digit will be 0, 1. So now we are good. So as soon as we have this, we can just write the like mod 100 for each expression, but I'll just skip writing. So you can write mod 100 because 7 to the 4th is not 1, but 7 to the 4th has a remainder of 1 if you divide by 100. That's basically what that means. So now we can just say, we can take the power of this, any power of this, our choice. So we can get close to this guy. 2011, we just want to make a multiple of 4. So 2008 is a closest number. So 2008, if we divide this by 4, So you will get 502, right? So meaning that if I take the 502nd power of this congruency, so you get 7 to the 4th to the 502. And then we are going to multiply this by 7 to the 3rd, because we want to get this guy to be like 7 to the 20, 11. So because when you multiply 4 by 502, you got 2000, like 2008, and then plus 3 will be 2011. So that's just basically what we are interested. But at the same time, 7 to the 4th is 0, 1. If you take the any power of 0, 1, you still get 0, 1. And then 7 to the 3rd was 43. So that is 43. And this is mod 100. Okay, so then if you multiply that, so you get 43 mod 100. So meaning that this is our remainder. If you divide this huge number by like 100, and we are interested in the tens digit, so the tens digit is just 4. So that is choice D. And that was number A. So here's the next question. So number 9, R is the set of 9 different integers, and 6 elements are given, 2, 3, 4, 6, 9, and 14. What is the number of possible values of the median of the R? So like you can just kind of start with somehow your like optimal values, or another way of saying that, maybe we can start with some like boundaries just to see what would be the least and the largest number to determine at least the range. So we are told 9 different integers. Okay, keep that in mind. And we have like 6 numbers are given, and then we need 3 other numbers. So 1, 2, 3, yeah, 6 numbers. So let's say other 3 numbers are the smallest 3 numbers from these given numbers. So 2, 3, 4, like 6, 9, and 14. In this case, since we have 9 numbers, the 5th number should be our middle number. So 1, 2, 3, 4, 5. So that means this has to be median. And I didn't really find any values for the XYZs, which if I want to, I can try finding. So because we are told the median is 3, so I can just choose anything that I kind of like to choose. Like I can say this is like maybe like 0, this is -1, -2. So I think that should be fine. So you can choose some other like variable as well, like numbers as well. It does also work. But median in this case is just 3. So that is the least number we can have. We cannot have 2 as our median because we have only 3 other numbers that we can add. So the middle number will be 5th number. And the other way around, so if you say X, Y, Z are the largest numbers, so you can say 2, 3, 4, 6, 9, and 14. And X, Y, Z, let's say those are like 3 numbers that is larger than 14, but they are all different. So the 5th number, 1, 2, 3, 4, 5, is 9. In this case, median is 9. So if you play with these X, Y, Z's in between those like numbers around these numbers, you can actually get any other like values in between 3 and 9 as your median. So if you like to find, you can find it. But the least we can have is 3. So the largest is 9. So 3, 4, 5, 6, 7, 8, and 9. These are all good. So we have 7 different possible options for this. Okay, so that was number 9. And the number 10 is the kind of like logic at some degree. We are given that the toothpicks are used to make the grid that is 60 toothpicks long and 32 toothpicks wide. How many toothpicks are used altogether? So like whenever you have some sort of question like this, you really want to kind of see a kind of generalization of what you're trying to do, because this is somehow involved. So for that reason, like think about the most basic option. Let's say we are just interested in this one. If there's only, let's say, 1 square, or another way of saying, if this is like 1 by 1, rectangle. So you have two horizontal, two vertical. So you have 2 plus 2. That's something. But if you have like maybe not one only, maybe we have 1 by 2. So let's think about this option now. So we have 1, 2 horizontal, 1, 2 horizontal. So like when you have 2 by 2, 2 by 1 actually, let's go with this. So we have 2 horizontal, 2 horizontal, which is 2 times 2, plus we have 1, 2, 3, which is interesting. 3 times 1, which is basically 1 more than 2 times 1. So maybe this might help a bit, but if that doesn't help, so we can just make this slightly involved just to kind of see. Let's say we want to do this this big. So you can kind of extend this as well, and then you will have something right here. So you will have this, you will have that, this one, and this one. So let's kind of try now. This is what, 2 by 3, right? So this is 2 by 3 or 3 by 2, either way. So when you have like 3 rows, you have 1, 2, 3 in this row, but we have 1, 2, and 3 rows, which is 3 times 3. So it was 3 by 2. So the number of rows was 2, but we multiply this 3 by 1 more than that number of rows because we just have to like close the square. And then this was 1 by 1, but we had 2 by like 2 times 1 and 2 times 1. Maybe we can write that way. And similarly, we have 1, 2, 1, 2, 1, 2, 1, 2, but we have 1, 2, 3, 4. So instead of expecting 3, we have now 4 times 2, which is the 8. So I hope that was kind of somehow helpful to see what's going on. So to find the, let's say, answer to our question, so this is what we are going to do. We have 60 toothpicks, right, long. So if you take like 1, 2, 3, all the way to the 60, this is also 60, this is also 60. But when you have 32 wide, maybe I can take this as wide, there will be 33 of those horizontal lines. So which is going to be 60 times 32 plus 1, which I will let you explore if you can make this in general and make a formula. And that's the number of horizontal ones. And if I want to find the vertical ones, we have 1, 2. I mean, like if you have like how many, like long, which is 60, right? So we have 60, but when you do this, let's say we have, this is 1, this is 2, like vertical squares, that will make 3 kind of vertical lines. So which is 1 more than this one. So which is why we just say this is going to be 60 plus 1 vertical lines. And each line will have 32 toothpicks. And then that's what we are going to multiply and add them. So 60 times 33 and 61 times 32. And you can just kind of multiply, or you can just split like maybe 33 as 32 plus 1 and maybe do that way. So either way, you will get the answer 39 32, which is choice, I guess, B. So I hope that was clear. I'll continue a bit more, but that was the second part. And I will also add more like explanation, maybe practice question regarding for some of the key topics. If you feel like some of the question you actually couldn't get it right, so you can look at those additional stuff just to practice on those skills. Anyway, I'll see you in the next video.